Hi everyone, it's Paddy here from arithmetichub.com, thanking you for choosing this video, but reminding you that whilst this is one method to solve questions like this, it's not the only method. With that being said, let's explore this concept a little bit further.
Hi everyone, so today we're going to look at adding and subtracting fractions. Now, this can become a little bit complicated, but to start with, we're going to have a look at adding and subtracting fractions when the denominator is the same. So when we're looking at fractions, we need to remember our parts of a fraction. We've got our numerator, which is the top part of the fraction, the denominator, which is the bottom part of the fraction. So what we're looking for here is adding and subtracting fractions where the denominator is the same. So if we've got the method for this, let's have a look at it first. It says, number one, when the denominators are the same, it's just add or subtract the numerators. So if you have denominators that are the same, all you are going to be doing is adding and subtracting the numerators, whichever it is. If it's an add, you add. If it's a subtract, you subtract. And then part two says, do not add or subtract the denominators. They stay the same, okay? So this should say add or subtract the denominators. The denominators, they're always going to stay the same, okay? So let's have a look in these questions. If the denominators start the same, then the denominator stays the same. Let's see if that's the case for these. So we've got 3/4 and 2/4 here, okay? Well, you can see the denominators are the same. So when the denominators are the same, it's basically saying, right, okay, we've got 3/4, 1, 2, 3/4 shaded there, 3/4, and we're adding 2/4. So if we're adding 2/4, it would look like that. So it's just a case of, well, how many total quarters do we have? Let's see if this makes it a little bit clearer if I do this. How many total quarters we have? Well, we've got 1, 2, 3 quarters there, and 1, 2 quarters there. So in total, we would have 5 quarters if we added them all together, wouldn't we? And if we check that and look at it, does it make sense? Well, yeah, the denominators stay the same because we're adding quarters. And then all we do is we do the numerator, add the numerator. 3 add 2 is going to give us 5. So if the denominators are the same, they stay the same, and then just add the numerators. That works up here as well with this one where we've got 4/9 minus 3/9, okay? Because all you would do is say, right, denominators are the same, this is in ninths, this is in ninths. So if the denominators are the same, all we do is we do a subtraction of the numerators. 4 minus 3 is going to give us 1. Our denominator, we don't have to do 9 take away 9 because that would leave us with 0. Our denominator just stays the same, so that just stays in ninths. 4/9 minus 3/9 is going to give us 1/9. Nice and easy, lovely, okay? The only thing is, sometimes you have questions that look a little bit like this. But again, we follow the method. When the denominators are the same, it's just add or subtract the numerators. Well, we can see the denominators are the same. Fifths, fifths, fifths. So the answer is also going to be in fifths. And all I would do is I would add the numerators together. 3 add 1 is going to give me 4. 4 add 2 is going to give me 6. So my answer will be 6/5. Same for this one. Check the denominators, are they the same? Yep, tenths, tenths, and tenths. So what I can do if I want to is I can already put tenths as my answer there and then do my subtractions. 9 take away 3 is going to give me 6. 6 take away 4 is going to give me 2 for 2/10. Now we're going to have a little look at what this looks like when it's a little bit more complicated than the denominators aren't the same. Okay, so let's have a little look at this then, when we're adding and subtracting fractions still, but now we've got denominators that are different. And as you can see over here, it's a far more complicated method when the denominators are different, okay? So let's check in with the method, okay? We'll go through the method first. When the denominators are not the same, we need to find the common denominator. So we know these are our denominators, the bottom part of the fraction is a denominator. So we need to find the common denominator. And what that means is we need to find a denominator that both of these would share if you were looking at them as equivalent fractions. Now we've looked at equivalent fractions before. Equivalent fractions are fractions that are equal, fractions with the same value. So if we've got 2/3, we might say, okay, well, an equivalent fraction would be 4/6. An equivalent fraction would also be 20/30. They are equivalent fractions. So we're going to have to use our equivalent fractions here to find the common denominator, a denominator that's shared between both of these fractions, okay? Second part of the method. To find the common denominator, find the lowest number both denominators are factors of, okay? So what we would need to do there for this particular method is we might have to know our factors really well. Now, factors are hopefully something you've come across an awful lot before you come across any questions that look like this. Factors, if you remember, are when, say for example, we've got 6, we set up our factor tree, 1 and 6 would multiply together to give you 6, 2 and 3 would multiply together to give you 6. So the factors of 6 would be 1, 2, 3 and 6, okay? So when we are finding a common denominator, sometimes we can use our factors to be able to help us out with that, okay? Or multiply the denominators together and use the answer as your common denominator, okay? Now that's always going to work, and that a lot of the time will be more efficient than trying to find factors. It's just if you're really confident with your times tables and you can go, actually, I know that these are in the same times table, then that might be really helpful with questions that look like this, which is the one we're going to go through, where you might use the top method rather than the bottom one. Number 3, whatever you multiply the denominator by, you multiply the numerator by, and I've written equivalent fractions there because it's the same thing. We're looking at equivalent fractions with this, so we would need to find equivalent fractions to be able to add and subtract these fractions, okay? And the final bit says, number 4, it's exactly the same. Once you've got the common denominator, then you do the numerator, add the numerator, or the numerator, subtract the numerator, and the denominator stays the same as it would have been if you'd already have had the numerators, no, if you'd already have had the denominators, sorry, the same like we looked at earlier in the video, okay? So, that's an awful lot of talking. Let's see what it looks like. Sometimes it's just easier to see what it looks like, isn't it? So, first question here. 2/3 add 3/4. First part of the method, when the denominators are not the same, find the common denominator. This denominator is 3, this denominator is 4. Those denominators are not going to be the same, are they? They're not the same. So, there's 2 ways we can do this. Now, what I might do is I might use the first method to find the common denominator, find the lowest number both denominators are factors of. So what I could do is I could write down my first sort of 5 of my 3 times tables, can't I? 3, 6, 9, 12, 15. And then I could do that with my 4s as well. 4, 8, 12. And what I've noticed straight away here is actually both of these are factors of 12, aren't they? Because if we write the multiples of them down, then we're going to find 12 in both of them. 12 is in your 3s and 12 is also in your 4s. So if I would look at that, I'd say, right, okay, the common denominator could be 12. But for this type of question, actually the second part of this method might have worked just as well. Multiply the denominators together and use the answer as your common denominator. Well, I could do 3 times 4. 3 times 4 is going to give me 12. Let's just check that. 3 times 4 is going to give me 12. So actually, I didn't need to do this method where I wrote out the multiples and found the factors, did I? Because I just knew that 3 times 4 was going to give me 12. And actually, this one would have been the more efficient method there. We can see, considering how much we've written those kinds of things, can't we? Okay, so 3 times 4 is going to give me 12. So for this, my common denominator, I know, is now going to be 12. It's an addition, so I'm going to put my addition in there like that. Okay, so now I have to think, using my equivalent fractions, what have I multiplied 3 by to get to 12? Well, I know that 3 times 4 is going to get me 12. 3, 6, 9, 12. 1, 2, 3, 4. 4 lots of 3 is 12. So I've multiplied it by 4. So I'm going to write on here times 4. I've multiplied it by 4. So if I've multiplied the denominator by 4, then I need to multiply the numerator by 4, as it says on my part 3 of my method here. Whatever you multiply the denominator by, you multiply the numerator by. I've multiplied the denominator by 4, so I need to multiply the numerator by 4. 2 times 4 is going to give me 8. Now I'll come over to this side, and so what have I have to ask myself, what have I had to multiply 4 by to get to 12? Well, I know that 4 times 3 is going to give me 12. I can check that here if I want to. 4, 8, 12. 3 lots of 4 gave me 12. So what I would have done is I've multiplied it by 3. So then what I would do is I would say, right, 3 times 3 is going to give me 9, because I need to do the same to my numerator as I've done to my denominator. Multiply my denominator by 3, so I need to multiply my numerator by 3. Now what I've got is 8 twelfths at 9 twelfths. Now the denominator is the same, and because the denominator is the same, I can now do this addition. The denominator, when we do these additions or subtractions, stays the same, and we do numerator add numerator. 8 add 9 is going to give me 17. So my answer is going to be 17 twelfths. Okay, let's have a look at this one. Now, this one is slightly different because I actually think the first method might be more helpful here, okay? So, let's look at the two methods. First things first, when the denominator is not the same, find the common denominator. This is 6, this is 9. They're not the same, so we're going to have to find the common denominator. Okay, let's look at the first method. To find the common denominator, find the lowest number both denominators are factors of. Okay, 6, 12, 18. Actually, I know my 9s, and I know 9, 18. So I know that actually both of these are going to have a common denominator of 18, aren't they? So I can put 18 as my common denominator. And that's a really simple multiplication for both of these sides. Because what I would do is say, right, what have I multiplied 6 by to get to 18? 1, 2, 3. 3 lots of 6 gives me 18. So I've multiplied it by 3. As it says over here, whatever you multiply the denominator by, you multiply the numerator by. So I would do 4 times 3 is going to give me 12 over 18. Then on this side, I would do exactly the same thing. So, what have I multiplied 9 by to get to 18? Well, I've multiplied it by 2. 9 times 2 is going to give me 18. So I need to do the same to my numerator as I did to my denominator. 2 times 2 is going to give me 4. And now I can subtract them. Denominators are the same. So I keep the denominator as 18, and I do numerator, take away numerator. 12 take away 4 is going to give me 8 for 8/18. I'm just going to rub this one out so we can see how different it is when we do it the other way around, okay? So have a little look at this just so we can get to grips with what this method looks like, how sort of quick it was, and sometimes how it can be a more efficient method, okay? So let's have a look if we do it a different way. Let's have a look if rather than doing it like that, what we do is we multiply the denominators together and use the answer as your common denominator. Okay, so what I'm going to do here is I'm going to do 6 times 9, which is always going to work. What I can always do is I can always multiply the denominators together. 6 times 9 is going to give me 54. So now my common denominator is going to be 54. I'm working in 54ths. So straight away, it's a little bit more challenging, isn't it? Okay, what have I multiplied 6 by to get to 54? Well, I've multiplied it by 9, haven't I? So I'm going to have to do the same to the numerator. So I'm going to have to do 4 times 9. 4 times 9 is 36, okay? So I'm going to do 36 over here. Then what have I had to do to 9 to get it to 54? Well, I've had to multiply it by 6. 9 times 6 is going to give me 54. So then I would do the same for my numerator. 2 times 6 is going to give me 12. Then what I would do, just to make sure that I wasn't making any mistakes, first things first, as I put 54 as in my answer over here, because we know that's going to be the common denominator. The denominators, when they are the same, stay the same in the answer. And then what I would do is I'd say, right, okay, now I've got 36 minus 12, still at the hardest subtraction, but just to be safe, what I'll do is I'll put it in a column method. 6 minus 2 is going to give me 4, 3 minus 1 is going to give me 2. So my answer is 24 over 54. Now what you'll hopefully notice is actually this way wasn't as efficient and wasn't as quick to be able to get to an answer this time. Usually it is, usually this way is faster, but sometimes it's the case that actually it's faster just to be able to say, okay, I can find the common denominator using what I know. I know that 6 times 3 is 18, I know 9 times 2 is 18, so I can use that to find the common denominator. Now, let's have a little look at this one, because this one is one of the hardest types of questions you'll probably get in your calculations, I think, because there's just a lot of steps to do. So, very similar to this, we've got 2 3/5, add 1 2/3. Now your problem here is that we've got mixed numbers. Now when we've got mixed numbers with this, what we immediately have to do is we have to convert them so that they are improper fractions. We know how to do that, but it's just another step to add to this already massive list of steps. Okay, so what I would do is I would do 2 times 5 is 10, 10 add 3 is 13, okay? So 2 times 5 is 10, 10 add 3 equals 13. So I know that I've got 13 over 5. As my 2 3/5 is the same as 13 over 5. We're going to do the same for this one. We do our whole multiplied by our denominator. 1 times 3 is going to give me 3, and then we add the numerator. 3 add 2 is going to give me 5. The denominator stays the same, and the numerator is now going to be 5 rather than a mixed number. Okay, now what we've got is another example of saying, right, okay, we're having to add fractions, but the denominators aren't the same. So what I would do is I would say, right, okay, what can I multiply both of these by? I could say that actually I know, because these are quite low numbers, that 5 times 3 is 15. I could just do it this way where we multiply them both together. Okay, 5 times 3 is 15. So my common denominator is going to be 15. And all I would do is I've said, right, okay, 5 times 3 was 15, so I need to multiply 13 by 3. 13 times 3, I can just say, right, well I know 12 times 3 is 36, add one more 3 is 39, or I can really quickly go 13 times 3, 3 times 3 is 9, 1 times 3 is 3 for 39. You can do a little bit of extra working out, but already we should be able to see just how much working out this type of question is requiring. Okay, what have I had to do with my 3 to get it to 15? Well, I've had to multiply it by 5, haven't I? So 3 times 5 is 15, so I have to do the same to my numerator. 5 times 5 is 25. And now I need to add them. 39 add 25. I'm probably going to put that into a column method as well. So there's an awful lot of steps to this type of question. 9 add 5 is going to give me 14. 3 add 2 is going to give me 5. Add the 1 is going to give me 6. So my answer is going to be 64 over 15. So there's an awful lot of steps to these types of methods. Just be careful, stick with the method, okay, and make sure on every step, have I done what's been asked of me. When the denominators are not the same, find the common denominator. To find the common denominator, you can use either of these two methods. Make sure you find your equivalent fractions, so you've multiplied the denominator and the numerator by the same thing, and then once you get to the end, please don't make the mistake of subtracting the denominators or adding the denominators together. The denominator stays the same, and then you add or subtract the numerator.
If you found this video useful, then I would massively appreciate you liking the video and subscribing to the channel. If you want to explore more methods or practice using the method we've looked at here, why not check out the teacher videos at arithmetichub.com. Arithmetic Hub has videos just like this on different methods, specifically targeting areas needed in Key Stage 2. There you can practice one particular skill, or generate your own sets of calculations designed to challenge your understanding of all the topics covered in Years 3 to 6.